Welcome back to Teacher Class, and this is our discussion for PSLE last minute revision for set number D. And let's look at our first question here from Nanyang Paper 1, question number 15. So here says that Junxiang uses 4 letters A, L, M, and N to form a pattern. So from here, you know that this is actually a pattern question. And the first 25 letters are shown below. And what letter is in 338 position? So the first thing you know that this is our targeted number. This is our targeted number. Next, we are given this pattern and we need to find what is actually the patterns that is actually occurring here. So if you look carefully, KLMM, KLN is one thing. It's repeating KLMM, KLN, KLM, KLN, and that's basically what happened. So this is what I call as actually one set. Means that this set is being repeated many times. And now I want to find what is the 358th position. So the next thing that I should find is how many letters are there in one set. And if you count 1, 2, 3, 4, 5, 6, 7, you will notice that there are 7 numbers. And now, what do I need to do? Once I found all this, what do I need to do? So what I need to do is to actually use the targeted number, which is 338, divide by the numbers I have in one set. Okay, or I should say the number of letters I have in one set, which is actually 7. So I just divide 338 divided by 7. So 7 times 4, 28. 8 times 7, 56. Then 2 as my remainder. And from here, I actually know this. 48 remainder 2. From here, I actually know this. 48 basically means the number of sets, or I should say number of full sets, means that all the letters are in. All the letters are in, yes. It's 48. Then I have extra 2 more, which is what? K and L. And I know that 338 is the second, or I should second letter in the set. And you can see, what is the second letter? Basically is L. That's why the answer is option number 3, which is L. Okay, so very simple. As long as you see this is 2, means that the second letter, or the second number, or the second shapes depends on the question. If it's 3, the third one. If it's 1, first one, or and etc. Okay, that's all for this question. Let's move on to our next question. Our next question is from Nanhua, paper 1, question 24. So here it says that a rectangle PQRS is folded along its diagonal PR as shown below. Given that the angle PRS is 23 degrees, as you can see here, find angle QRS after the fold. So the key thing here is about the folding. You should understand that if this is the angle, as long as it's folded, it will still be the same. Okay? So first thing I can identify is here is 23. As you can see, here is 23. Which means that here will also be 23 degree. Make sense? Good. Now the next part is that since this is a rectangle, I know that all the side here are actually all 90 degree. All the side here is 90 degree. Which means here will be what? Or I should say the angle QRP will actually be 90 degree minus 23 degree. And that will be equal to 67 degree. And as you can see, this is actually being folded. This is actually 67 and this is being folded downwards. Which means that this whole part actually is still 67. Correct. Let me just quickly highlight this. This part is actually this whole thing. Okay? Now, my goal now is to look for QRS, which is here. And of course, I know the whole thing here is 67. Part of it is 23. So the angle QRS would be 67 degree minus 23 degree, and that is equal to 44 degree. And I'm done with this question. Simple. Again, folding question is actually trying to help us to understand that the angle is still to be the same even if it's folded. Okay, so let's move on to our next question. From Now Paper 1, question 23. Now, this question here says that the figure below is made up of triangles and rectangles. Let me just highlight this. And the area of rectangle is twice the area of triangle. Okay, this is a keyword. Let me just put a star here first. And here continue to say that 1/8 of the rectangle is shaded. A very keyword here, shaded 1/8 of the rectangle. So I actually can say that this rectangle, the total unit is actually 8. But this part, which is the shaded part, is 1 unit. That's why the rest here will be 7 unit. You know, right? 8 minus 1 is equal to 7. Okay? And what is interesting is the area of rectangle is twice the area of triangle, which means that this triangle should be half of the rectangle. So 8 divided by 2 is 4, which means that the triangle unit is actually equal to 4. But since a big part here, or I should say small part, is 1 unit, so here should be 3 unit. Because what? 4 minus 1 is equal to 3 unit. And now the question now asks, what is the ratio of the shaded area to the total area of the figure? So what is the shaded area? I'm not sure the exact area, but I know it's equivalent to 1 unit. Okay, 1 unit. But what is the total? That will be what? 3 plus 1 plus 7. Remember that the shaded part is overlap. That's why it's counted once only. Okay, so the shaded will be 1, and the total is 3 plus 1, 7, which is equivalent to 11. 1, 2, 11. And we are done for this question. Okay, let's move on to our next question. Question 20 from Nanyang, paper 1. Okay, so let's look at this question. Going to stack 13 unit cubes and glue them together to form the solid below. So you have given a solid here, and here says 13. So it's very important to know that there's 13 there, and we can try to count to make sure that there's no any hidden cubes. Because like example, if there's one at the bottom here, you might can't see, right? So let's try to count first. 1, 2, 3, 4, 5 at the bottom, 6, 7, 8, 9, 10, 11, 12, 13. So it's exactly 13. There's no hidden cubes behind, okay? And now we are supposed to get from the side view. Side view is here. Okay? Means that we need to try to think and draw here. Okay, let me just scroll down. So as you can see, this will be the left one. Left, 1, 2, 3. So means that at the bottom, I should have 3. Let me just quickly draw here, 1, 2, 3. Then on top, here I have 1, here I have 1. So I have 1 here, 1 here. And top, I have only 1 here. And top, I only have 1 here. So this will be it, how it looks like. Okay, 3, 2, and 1. And again, a reminder, please draw using pencil. Why? Because if you draw wrongly, you can erase it. And using ruler. Please draw using ruler and make sure it's nice. Okay, my drawing here is not nice. I didn't use ruler, but please try to use ruler. Okay, thank you. Let's move on to our next question. That'll be question 29 from Peihua School. So here say that Lina had 800 in her wallet. Okay, this will be the keyword, the key idea here, 800 in her wallet. She spent some money from January to May, and the line graph shows the amount of money in her wallet at the start of each month. Now, a very, very interesting one. Here say what? The line graph showed the amount of money in her wallet at the start of each month. Now, usually question, especially in line graph, they always give at the end of each month. But this time they are giving at the start of each month. Okay, this is actually a very interesting question to note. So as you can see here, they have labeled this is the amount of money at the start of each month. And you have January, February, March, April, May here. So let's try to find out the value on the graph first, okay? So January, we have 750, but we can't just assume here is 800, right? We need to make sure first. 800, 850, 900, 950, 1000. Yes, correct. This is 800. So let's write here, 800. So for February will be 700. So you can know that each bar actually increased by 50. March is 500. April is 50, 100. And May is 0. So something to note is when you identify the value for in the graph, please make sure you double check, because if you identify wrongly here, the rest will be gone. Okay, so double check 800, 700, 500, 100, 0. Okay, again, remember 800 is the start of each month. Means that they have the money at the beginning. So January of 800 means that you haven't spent any money yet, because 800 amount. But when it comes to February, it only left with 700 at the beginning, which means that 800 minus 700, let me just write here, 800 minus 700 is 100. And this 100 was actually spent on January. Okay? So the same thing, 700 minus 500 is 200, which means that you spend 200 on February. And March to April, 500 minus 100, that is 400, means you spend 400 on March. And April to May, minus 100 minus 0, that's 100. Means that you spend 100 on April. And May, I don't have any more. Now, the question A now asks, in which month did Lina spend half of the money she had at first? Now, the money that she had at first is what? 800. And half of 800 is what? 400. Then you know it's which month? March, sorry. So the answer for A is March. That's all. We are done for A. Now let's look at B. The amount of money Lina spent in each month can be represented in the pie chart. So complete the pie chart with the month that represents the amount of money Lina spent. Write J for January, F for February, March, M for March, and A for April. So let's quickly just go through here. So which one have the most? Half of it. Of course, I know it's March, right? Because I just found out it's 400. It's half of it. So this will be M. And which two have actually the same? But you can see, right, this is 90, this is half. So 1 and 3 is supposed to be the same. I know it's January and April. 1 and 3, so it's January and April. And of course, the one that have a quarter of 800 is 200. So it's February. Okay? And that's all we done for this question. J, F, A, M. Okay? Done. Let's move on to our next question. From Nanhua Paper 2, question number 10. So here says that the average score for a mathematics test in the class of students was 80. But later, it was discovered that the score of one student was wrongly recorded as 48 when each should be 98 marks. After correcting this score, the average score of the class increased to 82. How many students were there in the class? So let's try to find out what's the change, okay? And there are changes in two parts. First part is the average. The second part is the total score. So let's try to look at the changes in the total first. 48 and 98, which means that if you change, there'll be a difference of what? 98 minus 48, which is 50. If it's changed, it actually have 50 scores difference in. And what's the changes happen in the average? At first it's 80. Let me just quickly like here 80, and later increase to become 82. So which means the changes in the average is 82 minus 80. And that's how many average point? 2. And you can say that the average is changed because there are changes in total. Correct? So I can do what? To find the number of students, I just need to divide 50 divided by 2, which is 5. You might be asked, hey teacher, why need to divide? Because average is usually what? The total divided by the students, right? And now total divided by the average, then you can find the number of students. So the answer is what? 25. That's all done already. Okay? So let's move on to our next question from Patron Paper 2, question number 4. So here the question says that the figure below is made out of two identical squares, ABCD, GJKH, and two identical rectangles, EDFA, EFDA, and BCHG. The perimeter of EBCH is 56 cm and the perimeter of AJKD is 72 cm. What is the area of square ABCD? Wow, there's so many information here. But let's try to look at it together. ABCD, GJKH are identical. So which means that all the length are the same. Now just assume that here is A, here will be A. Then here will be A. Of course, here will also be A. And two identical rectangle EFDA, BCHG. Which means that if here is B, let me just write here B, here will be what? B. Makes sense, right? Now let's look at here. The perimeter of EBCH is 56 cm. EBCH. Oops. EBCH means that it's up to here. Okay, let me just quickly highlight. EBCF is up to here. So, means that this 56 cm includes 1, 2, 3, 4, 5, 6. 6 things. Okay, so let me just add together. EBCF have how many A? 1. Let me just circle it. It will be good. 1, 2, 3, 4. So 4A. How many B? 1, 2. 2B. And that's equal to 56 cm, according to here. Now the next part. The perimeter of AJKD is 72 cm. AJKD, wow, is up to here. So what is included here? Let me just use here. AJKD is A, 1, 2, 3, 4, 5, 6. So you can say that AJKD involves 6A and how many B? It's kind of obvious, it's 2B. So plus 2b. And that's equal to 72. And from here, you actually can try to look at it here, right? 6a plus 2b is 72, 4a plus 2b is 56. So it means that their difference, okay, or I should just make it clearer. 6a minus 4a is equal to what? 2a. Okay, is 2a. 2b minus 2b, nothing. 72 minus 56, that's equal to 16. Which means that 2a is equal to 16, then a will be what? A will be 16 divided by 2, which is 8. Now I know that this ABCD is actually with side of 8 cm. So how to find the area? 8 times 8, which is 64. And of course, the answer will be 64 cm squared. That's all. We are done. Let's move forward to our next question from Pei Hua paper 2, question 11. And this is also a pattern question. So here says that Gopa uses cubes to form solids that follow a pattern. So the first 4 solids are shown below. Then a part of the solid is being painted. So as you can see, painted, unpainted, and total. And you can see for the painted one, you have 1, 4, 9, 16. And when you see 1, 4, 9, 16, the first thing that comes to your mind should be something we call it as perfect square. Okay, perfect squares means that something like this. 1 times 1 equal to 1, 2 times 2 equal to 4, 3 times 3 equal to 9, 4 times 4 equal to 16. And you can see, this is exactly if it's solid 1 is 1, solid 2 is 4. Okay, so solid 5 will be what? 25. Kind of easy. And number of unpainted cubes 0, 4, 18, 48. Oh, seems like it doesn't have any kind of nice pattern. Let's go on to the next one first. Total number of cubes 1, 8, 27, 64. And this is something that you might not be familiar, but it's something important to know. This is what we call it as perfect cubes. Huh? Yes. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. And you can see this all related back to the solid number, which is solid 4, 64. Solid 3, 27. Okay? So of course, if it's 5, will be what? 5 times 5 times 5 will be 125. Good. Next one. How to find the number of unpainted cubes? Now, of course, you can just use the perfect cubes, the total, to minus the number of painted. Then you will find the number of unpainted cubes, which is 100. Okay, simple. Let's move on. B. Which solid has 196 painted cubes? Now, if here is 196, then what will be the solid number? And of course, you know this is a perfect square. So what you need to do is just to square root 196. Okay, and you'll find out the answer is just press on your calculator and you find out the answer is actually 40. And we are done. So let's move on to question C. So question C here says that a total of 532 cubes are used to build a solid. How many unpainted cubes are used in a solid? So, okay, let me just write here. So basically, now I have here 5832 as my total. But now I want to look for my unpainted cubes. Okay. So the first thing that we can do is we need to find what is the solid number here. And again, I know this is a perfect cubes. So my first step, let me write here C, to find the solid number is I actually can do something similar. Just now I use square root, now I use cube root. Just press on your calculator, cube root 5832, and you will find out that the solid number is actually 18. Yes, 18. So of course, with solid number, you actually can find the painted cubes. So the painted cube basically is 18 times 18. If you press on the calculator, 18 times 18, you should find it's actually 324. So here it's 324. And now you want to find the unpainted. So how to find the unpainted? Simple one. The 5832 minus 324. So that would be 5832 minus 324. There will be 5508. And that would be your answer. You're done. So yes, we are done for set number D. And I believe that this question will be actually a good question for you trying to revise some of the question that we have learned, but we might have forgotten. So all the best in your preparation for PSLE, and we'll move on to the next set, which is set number E. Okay? Thank you. See you. Bye bye.